Stop having fun. Next time. Next time. Let's do some more LeetCode. Total waviness of a number in range 1 given two integers num1 num2 representing an inclusive range num1 waviness of a number is defined as total count of its peak and valleys. A digit is a peak and if it is slightly greater than both of the immediate neighbors. A digit is a valley if it is strictly less than both of its immediate neighbors. The first and last digit of the number can't be peak and valley. Any number with lower than 3 digits has a waviness of 0. Okay. Mamma mia, this is crazy. From 198 to 202, how many ranges we have? Bro, how? 120, between 120 and 130 we have 10 values I guess. 10 वैल्यू में बस इसको 3 ही मिला है. This is middle value is 2 which is greater than my this value and here we have the peak as 3 here. The other number in range have waviness of less than 3 values should be having the waviness of 0, but since my 120 will have 3 values. After that 121, 122, 123, 153, 5, 6. There's so many values, but why are we considering them? But here you are doing between 120 and 130, and between 4848 and 4848 we have to. There is a number 484 is the second digit is 8 is a peak and the digit 4 is valley gives waviness of 2. What I can do is like I can convert this to a string. I guess it will be easier for me to traverse over the element. I guess it will make a string num1. Who care about the output? I'll figure out later. Here I have a peak element of 2 and 3 here. Okay. Is my one peak, since one does not have the left value, it doesn't, it can't be peak right now, and after that we go back to the 2. Is my 2 greater than my 1, and greater than my next element? Yes, then it is peak element. I can keep on going to the in, I have to compare like 10 to the power of 5. The number can be so big. Right, but why are they only taking like 120 and 121 alone? Like, what about the other ranges? They are told us like representing an inclusive range of num1 and num2. So this should be including every values between them, right? Why we only have like 120 and 130? So 9 is bigger than my 1 and 8, and so 0 is less than my this thing and this thing, and even 0 is less than this thing and this thing. So value. So I have to check for 3 conditions. Not 3 conditions. I have to check. I have to check for 2 conditions. Either it should be less than my first value and second value, or either it should be greater than my first value and second value. The left value and right value. But this test condition is like bit confusing right now. Why they are only taking like 121, and they have 120 as a first number and they have the 130 as a second number, the last number in the range, I guess. And in between the 120 and 130 we have so many numbers, but they have only included 3 numbers. So are they saying like I can only include 3 numbers whatever the range is given? If that was the case, then I could have gone with the one. If I had to go from 198 to 202, where is 199 then? And where is 200? Uh, did I understand the question wrong? Should I ask the AI to explain the question only? All the other number in range have waviness of 0. How? You're saying like if I have 2 zeros, then I shouldn't include them. All the other number in the range have waviness. So if I take my range as 122, then that is not lesser or equal, I guess. What about the 123? Yeah, it is not lesser. Oh, I need to see. Now I understand. I Okay, the main test case was like we need is either my greater than the and right or less than my f right else skip. If we have to do some of all will be starting from let I will be starting from my nums one and if my nums two as a plus plus will happen. I have to check. Oh, this is interesting. I have to take the indices now. If my nums one of I can do nums one of I right since I have if the string nums of I is greater than my string num of I plus 1 and then string nums of 1 I is greater than my string num of I minus 1. Either this is true or should I put an else if or should I write a single if condition itself? Then we'll maintain a count. Let, uh, let me count it. And every time this condition becomes true, then I have to do count plus plus, and same goes for this thing. Only this thing happens if my current digit is. Uh, Wait, will this work or not first? Right? If I take my string nums of and string nums of 2.length, okay, string nums of I is greater than my so 1 actor. Will it compare first and then next number? It will be stuck. I guess this should end after else if my string num1 of I is less than my string num1 of I and then string num1 of I is less than my string num of I then it should include plus. I feel like they should if this is not working then I need to see what is it. Only if my string nums of I is greater than my string nums of I plus 1 and string nums of I is greater than my string nums of I minus 1 then only increase the counter. Otherwise if it is less than my I and less than my I minus 1 then only increase the counter. Let's see how much we get. Didn't I return the count? I'm getting 0. So what was the issue? So did my counter did not even work? Or did the loop did not even start? Hey, found a number. Let me let me write a temporary string so I'll be able to see the number. It is true. Mm, okay, 5 plus 1 here and same thing. I may one. Let me see if I'm getting my output printed first. Oh, cool. So what is the issue here? Um, this thing did not work. No, this thing is working fine. This thing is working fine, I guess. So what was the issue? Why my loop didn't run? Did the condition thing not even execute? There's something issue with my loop itself. Oh, now I understand. I see. There won't be there won't be 198 index in the string nums of I. So what I need to do is like I need to wait, we need to do something else since this one worked. This is I have used this thing to get the range of the numbers in between them. But since my I is imagine if my I value is 120 and if I'm trying to look for the 120th index, nothing exists. So what I need to do is like I only need to take the index from there. Can we just run a different loop for this thing? Maybe let me think how I can take the values for this thing. Instead of doing this thing, we could have done this one. Yo, yo, IIT guy. Uh, we run a different loop. If I run a different loop again inside this, then even if I run a different loop, then this index is like 198, which is pretty bigger. Or should I use an array to store the values inside this thing, and then after that we can just run a different loop and check for the each array's value, I guess, like 1 to 3 range, I guess. I mean, minimum 3 ranges or like maybe length of the current value. They really need to use array here. Oh, it's a dynamic programming question. I don't know what the fuck is dynamic programming. Problem of the day, man. Um, First time I understood the question, man, but what the fuck? I need to look for the looping thing, man. I guess this condition should work. I only need to fix this looping thing. I guess my solution will work. I'm 50% sure about that thing, but I don't know, like, will it work or not? Then how do I start my loop? Yeah, yeah. Yeah, I'm doing the brute force way. But I need to fix my loop, man. Since imagine if my I value starts with like 198 and the length of this thing will become 198 and this thing will become 202. And if I start looking for the ith value, which is 198, does not exist in the string. It's literally like 3 digits. More than that, if I use, then like it will be empty. Now I only need to fix loop condition. Let me think. In order to get the range of numbers, we have done this thing. So now I need to run over the loop and check if these conditions are getting passed properly. Only conditional matching is failing right now, I guess. How do I do this? If I run a different loop inside this, then that thing also will not work since my I is like 198. अरे अरे ये आ, इस इसके अंदर I can do different loop, but I don't think we can do with some other different way. We can take element equals string num of I and till my element dot length is exist, then till that, then we do this thing, I guess. This part should be inside this thing. I need to replace with j. uh, Yo Thor, what's up, man? Let me remove the print statement since I understood where the mistake was. It was out of range, so I was not getting any output, I guess. Now it should be working. If I change this back to this thing. No, don't say the answer, don't say the answer, don't say the answer. No, no. I think they should work, bro. Oh, still not getting anything. Wow, this is interesting. Oh, I'm doing the same mistake again. We should have used the normal number itself instead of using this thing. Let me use a number. Now we have the element and everything, I guess. But this is not even needed then, like for us. You only need to make this thing a string inside it, I guess. So what we have to do is like I2 string, I guess. Now this should work. Element becomes string here and goes till the end of the element and check if it is. Again, I have some different comparisons here. This should be element now, right? Since I'm using different name. Should I keep a simple name? Like element is pretty bigger number name I use. Oh god, please work. Oh, I'm getting two. Okay, this. Okay, this is not okay. Length minus one. Why are we doing length minus one? You mean till the last element? Is my conditions failing somewhere? Or maybe this condition is like literally wrong. Can we just take some different naming convention like at left and right something? Wait. First will be like current one. What? Change outer loop also should be num plus 2 plus 1. Here. Only that thing was wrong. Yeah, let me see. I don't think that will work. Oh, it worked for this first case. Let me let me write it clearly since my left one will be like left one will be like my element of I minus 1 and my right will be like element of I plus 1. Now we can replace the conditional thing itself. Don't sense. We are doing a different approach. Now we have this thing, you can just compare directly. If my current is greater than my left and current greater than my right, or current is less than my left and current is less than my right, any of these so that should work. What the fuck? Current, okay. 3 pointer question, I guess. Oops. Where did I make mistake now? Is it because of this plus 2 plus 1? What the heck? Why I'm getting zero? What the hell? Account is outside, right? My I is starting from nums1 and goes to nums2, and I'm making it to as a string, and I'm running another loop where I'm checking for the current element, which is my current element here. Arey yaar, shit, bruh. Silly mistake. Oh, why one is missing? Is it because of plus one here? Holy fuck. Even brute force was able to do like 78% is damn. How did other people solve this? Oh, I see. That's the reason we are doing plus one. I could have done less than equals to, right? Then, if I do less than equals to, will it not work? Plus one or less than equals to should work. Yeah, this works. How other people have solved this? Okay, this question was pretty much easy to understand. So, but yesterday's question was fucking crazy, bro. It drove me so crazy. What he's doing? If I is less than 100, then continue. Why? Why, bro? You could have done something x or element dot length is less than 3, then continue, bro. What the fuck you run? Okay. Anyway, like it's just an if condition, doesn't matter. And let number equals to I. Wow, he used a while loop. Oh, okay. He used the digit thing. What other people have used a digit thing? I guess convert a number to digit. I guess my center is greater than my right, and the center is greater than my left. So let me let me check. Will my previous solution will work? Like what are the rules for the previous thing? Maybe the J was the error there, I guess. But we already had the J thing here. Why this didn't work? I have to write an OR condition where I need to do what I need to do, like or my element of J is less than my element of J plus 1, and an element of is than element of J. Why will this not work? Okay, so this was right already. Like I wrote an else if, so that's the reason this didn't work. If I remove this thing and run, then it should throw an error now. Okay, and if I remove this thing and put it here, I'll say, will this work? It will say either one, right? Okay. What the hell, bro? Last time, why this thing didn't work? What the fuck? So already had the solution in hand, like, but this thing didn't work since because of the naming convention. Maybe INJ thing. I already had this thing already. I just, I mean, what do you say this thing? I refractored it a little bit in a neat way, but even this thing is working fine. I guess both the things are same, but yeah, instead of writing the whole thing, we didn't store it in a variable and used it. But when I tried to run this thing, I did not even get a fucking. Maybe because of this I plus one thing. Okay, if I do less than equals to, then this should work. I see. Oh, bro, shit. Okay, same thing. Cool. Okay, this is what I did. Most of the people are using S. I don't know why people use S. I will get confused, so I use element here. Why this guy's is too much spiked right now? What did he do? Okay, let us check similar questions since we understood the pattern, I guess. How to find a similar question? But how do we solve with the dynamic programming thing? Like they have given enumeration, I did nothing, bro. I just used two loops. It's done. But this is brute force, right? Pre-computation DP prefix some. Oh shit! This is fucking easy. What he's doing? He stored an DP array of max of 32 digits, and he put a max value inside it. And what he's doing then? Oh, he destructured the max. What the hell? And he goes till the max, which is constraints value, I guess. It can't go beyond this thing. And so D1 is like he's getting the digit, I guess, and he's getting the digit 2, digit 3. Okay, he's getting every digit separate by separate, I guess. And he compared. Okay, wow. Is this the most optimized solution? Once I learn DP, then I would be able to do this thing. Like, how on earth I'm supposed to think like that? Same reaction. Two lines for this task. What did you put? Most people said like nobody uses the JavaScript, but I guess like more people are using that. Uh, so only one way of doing this thing is like brute force way is this thing. Otherwise, you can go with the DP digit DP something. I don't know. People got digit DP. Wow, he also created a channel called as Code with Wix. Code with Mick. Let me see the solution if I'm able to understand the code. Okay, this is C++. Wow, interesting. So, that's one. Even the JavaScript solution was like 5 to 6 lines. Does DP gets longer in the C++? Have a nice day, please support. String simulation, string plus simulation. Oh, this is simulation. This is what we call a simulation. First time in my life, I've understood the question clearly and was able to do in the first go. And what is this now? Oh, he wrote a function. Wow, this is also good. I mean, he wrote it in a clean way. I like this. So, I don't think like there should be a right answer for this thing. Problem of the day. POT. Where can I find a similar question? What does zigzag conversion means? Oh, this question. This question is crazy. Let me think how if I'm able to come up with a solution for this question. Like I don't know how to do this, but I'll try. They have given me row number. I need to do something with the row number. Write a code that takes a string and make it conversion to the conversion given a number of rows. PayPal sharing, num rows 3. What does that mean? I have to shuffle this thing. What have we done? What is this? How the hell I'm supposed to think an answer for this thing? Only straight. I'm given a nums row. So nums rows can contain like only one num. So what does the nums row? Uh, wow, this is crazy. 0, 1. Here we have so many. How do I even write the thing like this? Convert as int nums row. PayPal is sharing nums row equals 3 and it becomes this. Wow. It was asked and before. How do even people solve this question, bro? Literally 2 million people have solved this question. I'm not even getting a fucking hint in my mind. Zigzag conversion. I'm going to ask AI to explain me the question. In short term, I understood the question, but Oh wow, it opened his site. The problem is asking you to arrange the string using zigzag pattern and then read it in a specific way. What question means a string s is given a number nums row 3. Write a string in zigzag form. So instead of writing the string from straight line, you place the character in the zigzag pattern. So you fill the character like this. Start from top row, move downwards row by row, then move diagonally back upward. Repeat this pattern until string ends. What the fuck? So the character are distributed like character that lands on the top line, character in the middle line, character in the bottom line. But importantly, movement down, down, down until bottom row. Then up diagonally until top row. Repeat. What the what the hell is this? After placing all character in zigzag, you read row 1 to the left, then row 2 to the right, row 3 to the left, combine everything into string. Holy shit. You're not rearranging alphabetically or sorting anything, you're simulating zigzag writing process, then flattening to row-wise in a single string. Fuck this question. What do you have? Show the tag. What is this minimum time visiting all point? Yeah, bro.
AI is changing the game for app development. Firebase is here to help. Easily build AI powered experiences into your web and mobile.
Made 8 attempts. No, like, oh, you have made too many attempts or stuff like that. No error like that was shown. And that's the issue. Because now I can use, let's say, Burfeed, use rocku.txt and just start hacking. Cohort guy, what's up, bro? Sarah.chen at shop try hack me, right? Only render 3 fields from the API response. So field shown is username, this, right? This is only shown on the front page, right? Created on which date, blah, blah, blah. But behind, I see user password, API key, internal nodes. See this? Now we can hash, like basically use track station or like even track it ourselves. So basically, those are just the normal stuff. Just lead code and learning go. Nice, bro. How's that going? The left panel simulates a login endpoint for admin account. Type any password and click.
But then the minimum time In seconds to visit all the points the given by points. You can move according to this route. In 1 second, you can either move vertically 1 unit, uh, move horizontal by 1 minute, or move diagonally square root. So, what is this? Geometry. Hell nah, I'm fucking weak in that. So my points start at 1 and 1, 3 and 4. Minus 1. There's minus 1. This is minus 1. Minus 1 and 0. It should be 5. Uh, what does it say? You're given a 2D array squares. Each square I represents a coordinate of bottom left point and the side length of square parallel to the x-axis. Square parallel to the x-axis. Find the minimum y-coordinate value to the horizontal line such that the total area of square above the line equals to the total area of square below the line. Answer within 10 to the power of 5, the actual answer will be accepted. Square may overlap. Overlapping area should be counted multiple times. What? How do you get this thing? Explain. Any horizontal line between 1 and 2. We'll have a 1 unit above it and 1 unit below it. The lowest option is 1. Okay. What about here then? How did you get 7 by 6? Binary search. One, six, 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 seven. Distance between two and one is one. Oh, should it answer be? Recursion solved by calling yourself base condition and to stop impressive case. Reduce a problem. Mental model. If I know answer for minus one, I can get for n. You're not looking at building a call stack. Let me go to the deep seek and ask this thing. Deep seek. New chat. Export. Wow, they have bought some category now. This is interesting. We need to teach recursion, backtracking, dynamic programming basics. The user wants to know basics to come up with a starter solution. Meaning want to grasp the fundamental concepts of how to start solving problems. They said other stuff vaguely. I should focus on core recursion and maybe mention memoization. Yo man, but we have educational provides simple example. It's talking to itself. What the hell is this? I like the way the DeepSeek talks with itself. I will structure the answer. Recursion definition, base condition, recursive cases stack, factorial Fibonacci emphasize thinking in terms of smaller subproblems. Backtracking is a form of recursion, explores all possibilities and undergoes choices. State space tree, generating permutations in between. Oh, engines from factoring. I used to sit with this problem that place. I don't know how to solve this, but I used to sit with the array. So, do you choose, explore, unchoose pattern, dynamic programming, optimization over the recursion and overlapping piece of problems and optimal substructures, top-down optimization. Quadrant tabulation and example Fibonacci with the domain. Knapsack coin change may be contrast with it. Let's go. Trust the process mindset. A function call itself and solve a smaller version of same problem and hits a trivial easy case, the base case. What was that just now? I know how to solve a problem in the simplest version. I had a answer for the smaller input. I could build an answer of mine. Two must-haves: base case and recursive case. How to reduce a problem and call yourself. When to stop without this infinite loop stack overflows. I see they have given the example in the Python, but I understand the code, so it doesn't matter. When you used to see a problem as, can I solve it by smaller and simpler instance of same problem? If you have sketched the recursive brute force first, then often start with the starter solution, backtracking, explore and undo. We are not learning something. Like, you want me to, you have to teach me, not say what is what. You you have to teach by step by steps. Yeah, take step by step and teach me what the hell is that and how to use them in the code and how to even think of the answer like that. Alright, forget the dashboard. Let me see if he's doing something really. Did I actually jump to a problem? Yo, teach me how to think in that and at least start first. So, plan accordingly. Make, make it make it look easier, but explain or so anyone can understand. Let's go. Absolute zero. Forget the problems for the moment. I'm going to teach you how to think at recursion backtracking. DP from scratch. Yeah, use the JavaScript. I forgot to say, bro. Use Python, then I might be able to understand. But think back again. Yes, sir. JavaScript. Yep. It was JavaScript. Yeah, yeah. You have a problem. You delegate a smaller version of same problem to the same function. This call is a trivial case, the base case. Then answer bubbles back up. The skeleton for any recursive solution is this. If problem is trivially small, then return trivial answer. Smaller problem, reduce problem. Smaller answer, solve small problem. Combine problem, small answer. Okay, let's train your brain on this pattern. First, recursive function countdown. Write a function countdown that prints from number 1 to n. Go. So, what is the task? Let me try JavaScript compiler. Deep Sigma boy. There's a YouTube channel. Be here. They become smaller. Smaller, smaller, smaller. This is fine. If my n equals to 0. So I have to depend console.code. I have to call the countdown 5. So will it provide me the answer? And method. Okay. Oops. For stuck going to exceed. I didn't. अगर 5 दिया तो why this many times it's coming? It should have returned it here itself. Man. Acha, I need to return. Ah, shit. 1, 2, 3, 4, 5, 6. If I want to print 5 times, then I need to 6. 8. What? Is my answer right, brother? Okay, there we go. It's fine, I guess. Now it's fine. Should I make it bigger? Now. Function backtrack state. If state is complete solution, record it, return. For each possible solution choices, apply choice. Backtrack. What the hell was that? What kind of bug was that? Backtrack updated state. Undo choice backtrack. Let us write recursion backtracking now. What will it have points backtrack? It will have my or path and result. What could be the base condition? Ooh. Result and path. So even my binary backtracking does not have any parameters. This is first time I've seen something containing parameters. Generate binary. If recursion depth is too deep, Stack Overflow happens. Ooh, even with the base condition. Alright, let's learn golang. Golang.
एंड एक्सेसरीज में बना रखा है इन लोगों ने कुछ, ठीक है। तो अगर मैं इसको कट कर दूं तो ये मेरे पास में कुछ आया है, गेमिंग एक्सेसरीज करके कुछ आया है, ठीक है। ये थोड़ा एक्टिव हो गया यार, सिंपल मुझे बताना है आपको। कोई अदर ई कॉमर्स साइट लेके देखते हैं, मिंत्रा लेके देखते हैं, जिसमें आपको थोड़ा और अच्छे तरीके से समझ में आएगा। भाई क्या हाल चाल? बढ़िया भाई। द कोड गाइस 01 अरे डीएस से नहीं कर रहा क्या आज? ठीक है। तो देखो यहाँ पे सोप नाम की कैटेगरी बनाई इसने और किड्स बना दिया यहाँ पे, ठीक है। किड्स नाम की एक वो बना दिया रूट। हाउ मच जेएस रिक्वायर्ड टू स्टार्ट जेएस? क्या बोल रहे हो? अच्छा पढ़ने दो पहले कमेंट। हाउ मच जेएस रिक्वायर्ड टू स्टार्ट React JS? My friend told me that JS and React JS were completely different. Please help. भाई ये समझ लो, React JS जो जावास्क्रिप्ट का क्या है आपका लाइब्रेरी है, तो आपको जावास्क्रिप्ट तो आना ही चाहिए ना सबसे पहले। कॉमन सेंस वाली बात है, ठीक है। नहीं बात हो रहा है नहीं भाई, वो तो हो गई, चल रहा है अभी भी। अच्छा लाइव हो गया अभी यूट्यूब पे, ठीक है। तो आदित्य जी आप पहले ना जावास्क्रिप्ट सीखो, ठीक है, उसके बाद रिएक्ट आप पे आना, क्योंकि जावास्क्रिप्ट सीखोगे तभी चीज़ों का पता लगेगा अच्छे तरीके से कि वेरिएबल क्या होते हैं, क्या होते हैं। मतलब बेसिक यार, बेसिक कैसे स्किप करेगा? हालांकि कर सकते हो, करने को कुछ नहीं है, लेकिन इधर नहीं घुसेगा कि कैसे, क्यों, कहाँ कहाँ क्यों हो रहा है। एक एक चीज़ को आप एक्सप्लेन नहीं कर पाओगे, ठीक है। द कोड गाय 01 यही चैनल ना तेरा? नहीं यार ये
बूस्ट இப்போ ஒரு கூல் மில்க் ஷேக்ல
ओ यूआरएल बताइए चैनल का यूआरएल
ஒண்ணும் இல்லையா பால்கனில நின்னுக்கோ அங்க வெயில் வராது
வெயிலுக்கு யார் பயப்படுறாங்க
இத பாரு நீ விக்கெட் கீப்பிங் பண்ணு அங்க நிறைய வெயில் வரும் வெயில் மற்றும் சீனியர்ஸ் ரெண்டையுமே தோக்கடிக்கணும் அதனால தான் பூஸ்ட் இன் புதிய கூல் மில்க் ஷேக் பூஸ்ட் மில்க் ஷேக் the new secret of mahi energy
Commander, welcome back. The station has been waiting. Let me show you around. This is the mech bay. Our armored units, silent but ready for war.
Welcome to the very first video of this series, Production Grade Go from Scratch, where we actually learn stuff, not just talk about how to learn stuff. And before we start, I want to make some things clear so that we have our priorities straight, and if people have questions, they have the answers right away. And if you just want to start with the content, just want to jump right into the basics of Go, you can skip it. You can find the timestamps below in the description. You can just skip right into it, because in the first part, for the first few minutes, I am going to clear up some questions. I am going to give some tips. I am going to give some advice on how to make this whole process more efficient for you, less time consuming for you, and more smooth. That's my goal. I just want to make this whole process of you starting with the language Go and you writing actual projects, production grade projects with Go. I want to make that timeline as short as possible, as smooth as possible, as stress-free as possible, and as valuable as possible. And I hope you will enjoy it, and I hope you will learn a lot. Okay. And the first question is, what are we doing here? If you have watched the previous video in this playlist, where I explain what are the series of steps that we are going to follow in this playlist to go from scratch to writing production grade Go backends. Then you will have some idea what are we doing here. So the idea is we are going to follow this resource, which is called the Tour of Go. This is recommended. This is one of the recommended resources from the Go official documentation, which gives a very high level overview, a very high level tour of all the features of the language Go, so that you are familiar with all the new concepts that come with the language, all the quirks of the language, all the syntactical concepts, all the syntactical differences with the other language. Basically, pretty much all the basics that you need to know to get started with the language, to have a very good understanding of the language, to write legit programs, useful programs in the language. Okay, and I have personally used this resource a lot of times, on and off, to get my basics clear, and that's why we are going to follow this one in this video. Okay, that's what we are doing in this video on a very high level. What we are exactly doing, I'll get to that shortly. So next, let's jump into the second question, which is, who is this for? If you're wondering, if you're watching this video and if you're wondering if this video is for you, then the answer is, if you want to learn the language Go without wasting too much time, without being a scientist, without being a master of the language, because unlike other tutorials, unlike other paid tutorials, free tutorials in Udemy, YouTube, where people dive into every single feature of the language, how every single concept works, the differences, the definitions and all. We are not going to follow that pattern. Those patterns are useful if you want to dive deeper into the language. But as I've already mentioned, the goal of this playlist is to start from scratch and to get to the production level project writing phase as fast as possible, as efficiently as possible, without going crazy. So that's why I have strategized how I am going to proceed with the series, and what are the steps that I can skip now, what are the steps I can add later, what is the most optimal sequence of the steps, and everything. I have thought a lot about how to structure this and how to make this as painless as possible. So yeah, so if you are here to learn the basics, or if you are here to revise your basics, because as we learn a new language, a lot of time it happens that you start with it, you learn all the basics, then you get busier, and then you leave it for some time. Then you come back after 2 months or 3 months. You have some idea, you have some kind of, you remember it in a very light way. So in that case, if Go is that language for you, where you have explored a while back and you remember some of the concepts and you just want to revise before you get started with the projects, then this is also for you. Because what we are going to do in this video is, we are going to go over all the basics in one video. I am not going to stretch it out to part 1, part 2, part 3, part 4. No, that's just waste of your time, waste of my time, and it gives people the idea that you have to learn a lot. I want to change the psychology a little bit. You can learn the basics in one video. You can learn it in one video, and we'll dedicate other videos to other areas of the language, best practices, how to structure your projects, how to read code and stuff. But I believe in long form content, even though YouTube algorithm favors short content because people have less attention span. But I am going to stick to this style because this works best for people who are serious, and this gives the idea that you can do it in one video. I think that's more important. Okay, so that's about who is this for. If you want to learn the basics of the language, if you want to revise the basics of the language with a single video, with the most efficient way and the fastest way, this video is for you. What are the prerequisites of the video? The prerequisites are, it's nice if you have experience in some other language, or if you're a computer science student or you have done a boot camp, or you're just curious and you've learned the basics of programming. You have done some kind of programming. It does not matter you have written big applications, big open source applications or big production style applications before. It does not matter. As long as you understand basic concepts of the programming, stuff like what are variables, what are arrays, why do we need loops and all. Because that is way too fundamental of concepts for me to get into and way beyond the scope of this video. So as long as you have some understanding of programming concepts, then you're good to go. This you can jump right in. Okay. Then what is this video? This is kind of similar to what I'll be doing here, but this video is basically a complementary resource for the Tour of Go. This is a recommended resource while people are learning the language Go. So this video is a complementary resource to
Mugs Choco Fills. Idilullada Adiradi chocolate filling. Manchoda Adiradi Choco Fills try panningala?
So our competitors tonight, Tanay and Marcus, who has proven to be an incredibly fast typist, 110 words per minute.
Now it is a very good point to show if conditions. It is pretty simple to wrap your head around. We have a condition which starts with if, and whatever the condition that is provided after that, there is no basis. You have provided a condition which should evaluate to either true or false. And if it is true, then this statement will run. Otherwise, it won't. That's pretty much all there is to. Now let's look at what are structs. So struct is one of the data types of aggregate types. We have two types of aggregate types. One is array and the second one is struct. Array is a collection of similar data types, and a struct is a collection of different data types. So this is how a struct looks like. You say type because struct is a Go's native type. The type, the name of the struct, and you literally write the keyword struct, and then you open a curly braces and you write different data types. You define what are the types of these fields. These are the fields of the structs X and Y, and beside them you write what are the types of those fields. Okay, and how do you use this struct? How do you initialize this struct? Here, if you see, you write the name of the struct, and in the curly braces you provide the values for these fields in that order, in the order that they were defined. Okay, now we write 1 and 2, and 1 will be assigned to X, 2 will be assigned to Y, and since these are integers, we don't see an error. This satisfies these two literals that we are providing. These satisfy the condition that X is an integer, Y is an integer, and we are assigning them to a struct which is called vertex. And now we can print this. We print it, go run main.go, we get this representation, string representation of struct, which is 1 and 2. There are also other things that we can do with a struct, which is, let's say we initialize a variable and we initialize this struct with X is 1 and Y is 2. Now we can access the fields of this struct. The struct has two fields, which is X and Y. We can access the fields using this dot operator. We can say whatever the variable is which we initialize the struct with, we can do v dot, and we can use X or Y because those are the fields of the struct. And we can also assign some values to the struct. Even though we initialized with value 1 for the field X, we can change the value of X after in the next statement, v dot X equals to 4. And now if we print v dot X, it will print 4 instead of 1. Now let's look at how pointers and structs work together, because this is very important. This is something that we'll use a lot when we are building projects. Now what we are doing here is we are initializing a struct with value X as 1 and Y as 2, and we are assigning it to V. And in the next statement, we are initializing another variable with name P, and we are assigning the address of V, the address of this initialized struct, and we are assigning to P. Now here what we did is, we using this pointer, we changed the value of X. Instead of 1, we made it this number. Okay. And what happens when we print V here? Let's print it and see what happens. Now we get this number, which is basically 10 to the power 9. We have 9 zeros here. Now that's the point. If we use a pointer and if we have a pointer to a struct, and using that we can change the values of the fields of the struct using a pointer to a struct. This concept is something that we will use a lot when we're actually building real world stuff. In this example, we are just looking at different variation of defining a struct and different variation of initializing structs. First run this example and then we'll see what's happening here. Okay. Now in the previous example, we had written it, we had written the fields this way. We had written X integer and then we have written Y as integer. Instead of doing this, since both these fields have the same type, both of these fields are integers, we can put them in the same line. We can do X comma Y integer. Now this is one variation of declaring a struct. Okay. Then let's come to initialization. What are the different types you can initialize a struct? This is one type that we have already seen. You can write the name of the struct and you can provide the fields in that order. So 1 will be assigned to X, 2 will be assigned to Y. And this is one way of initializing struct. The second way is you write the name of the struct and you can provide a key value pass. You can write the name of the field, in this case X, and you can provide a value. And then with comma, you can provide another value of I, Y, and colon 2. You can do it like this. If you don't provide an explicit value for a field, by default, since Go has this concept of zero value initialization, by default, Go will assign the zero value of that data type. In this case, since it is an integer, Go will assign the value 0 to Y. Does not matter whether you provided an explicit initialization value for Y or not. Go will assign the value 0 to Y. That is one way of initializing struct. Another way, what if you don't provide any fields? Just type the name of the struct and you initialize it. In this case, Go will assign the 0 value of both the fields to them. In this case, both of these fields are integers, so X will have 0 and Y will have 0. Then you can also do this. This is struct literal syntax, and what this means is this is kind of similar to this, but instead of providing the type vertex, P will have the provide pointer to vertex, and if you hover over it, v1 is a type vertex. If you look at it, v1 is a type vertex, but P has a type star vertex, which means P is a pointer which points to a struct which has the type vertex. It is a pointer to a struct. Okay? And that's why when we printed for v1, we got the result 1, 2. For P, we got the result 1, 2, which is a pointer, which that's why this ampersand, the symbol and stands for. Then for v2 and v3, we have 1, 0, because here we only initialize X with the value 1, and the Y was initialized with the 0 value. That's why we have 1, 0. And in this case, we did not initialize any of the fields. That's why X has 0, Y has 0. Now to wrap our heads around where do we actually use structs, we can look at a few examples of our open source repository. Let's search for the keyword struct here. Now structs are something, if you're a backend engineer or any kind of Go engineer, any kind of engineer, and you're using the Go programming language, structs are something you'll use a lot. Your day-to-day life will involve dealing with a lot of structs because it is a very versatile data structure and very commonly used data structure. If you get some JSON from front end, you have to parse it and store it into a struct before you can use it in your Go program. Because unlike JavaScript, you cannot use a JSON directly with your JavaScript object. Okay. You have to parse the JSON into a Go struct, and then you can use the struct. That is one use case of structs. Okay. Now let's look at some examples. We'll just skim through them to get a feel of how people are using structs. Okay. So this is one struct which has a field called plan ID and this of type string, and these are called struct tags. And what it says is the key is JSON and the value is plan ID. And it is a bit out of scope for now, but this basically means, let's say from the front end, from the client, we receive a JSON. We receive a JSON with this value. Say plan ID as 3. Okay. This is the JSON we receive from front end. So when we are trying to read it in our handler, okay, first we have to do is you have to take this request body and we have to parse it. We have to unmarshal it into a Go struct before we can use it. We cannot use it directly because it's a JSON type and it is in bytes. When we are parsing it, we can use a struct like this, which has a field, a struct field with Go's own convention. And here we are saying that we are using this struct and any JSON field with the key plan ID will be parsed into this field, this plan ID. So using these tags, these are called struct tags, and with the key JSON, these tags are one way of mapping JSON fields to our own Go's struct fields, because the naming will be different. In Go, we'll have camel case fields, and the styling of Go is a little different than what we follow in typical JSON based payloads. That's why we have struct tags, so that we can map the JSON keys into our own struct fields. So that is something a little out of context now, but something useful to remember for now. This is what a typical struct looks like, and we have more examples of structs. We have this one, invite users. There's a string and there's an array. There's a slice. We have not explored slices yet, and there are a lot of examples of structs in this code base. So you can notice it. First we have field names, then you have type, and you have tags. Depending on which application, which package is using it, we'll have different tags for a struct for different parsing mechanisms. Okay. So as you can see, structs are pretty versatile. We can store any type of data inside them. It does not matter what type is. In array, we can only store homogeneous data. In structs, we can store heterogeneous data. It can be an integer, it can be a string, it can be a slice, it can be a map, it can be anything, it can be pointers. Okay. So structs are very useful and something we'll use a lot. And this basics is enough to get us started with structs. Now, another thing about structs that I want to mention here is the capitalizing of the first character of the fields. And as you can see here, all the fields start with capital letters. And this is not a styling thing. This has a use case, as we have seen before. Capitalizing of fields and variables in a package in Go results in that variable or that type being exposed to code outside of that package. So for example, in this, we have this package called CMD, and this is another package called some test package. If we see the name here, and the package name is API v1 test. These two are different packages. Now, this package is using code from another package, from the CMD package, and it is using this struct, and it is importing that struct into this package so that it can initialize a new instance of it. What happens if we change this field from a capital R to small r? Let's change it and let's see what happens. And the moment we made it small case, as you can see, there are errors everywhere in the program, especially in those scenarios where we were accessing the field, this particular field of this struct that we were importing from another package. So that's the use of the capitalizing. If the first letter of that field of a struct is not capitalized, then we cannot access that field outside of that package. That's why we capitalize fields of a struct. And then we have arrays. As I said, arrays are a collection of same type of data types. Okay? That is the one-line explanation of arrays. So what we are doing here, we are declaring an array which has this type. It is a string and it can have 2 items. So this part, this 2 part, this is basically the size of the array. So when we say toString, when we say this, we mean this array is of type 2 items string. This size is the type of the array also. So this size is part of its type. So this array and this array, 3 string, these are of not the same types because it is of size 3 and it is of size 2. So that is one thing to remember. The size of the array is part of its type. Okay, next, what we are doing here, we are declaring a variable which is an array of length 2 of strings. And in the first index, we are storing the string hello. In the second index, we are storing the string world. We can access the indexes of the array using this syntax. The square brackets, and inside is the index number. And then we can print it, the index 0, the index 1, we can also print the whole array. The same way, instead of doing it like this, instead of declaring it here and initializing it this way, all the indexes, we can also use this syntax. What this syntax is, we can write the size of the array and we can write the type of the array. In this case, it is an integer of length 6. Then we can provide all the values in this order. 0, the index 0 will have 2, index 1 will have 3, index 2 will have 5, and so on. And we can print this. And let's run this. And as you can see, we have all the expected results. Now the 2 major points here are, 1, Go is a statically typed language, and second, an array size is part of its type. Now since we have these two facts, now arrays cannot be resized because a size of an array is part of its type. You cannot resize an array, you cannot reduce the size of an array, you cannot append to an array, you cannot do any of those things. An array is just a constant that whatever value you initialize it with or whatever value you push to it, and that size will always be the same. You can only push up to whatever value you initialize with. Arrays cannot be resized, and that is the reason you will not see arrays being used as frequently in real world systems. We will still use it when we have a fixed number of
இனிப்பின் அசல் சுவை Cadbury Dairy Milk.
elements that we know the value of beforehand. But in most cases, we use another data structure provided by Go, which are called slices. And this is how we can make a slice using an array. And if we try to run this, we get this result of 3, 5, and 7 because this syntax, this indexing syntax that we use to slice, to create a slice out of an array, this is how it works. In the first part, we have a opening square bracket. In the first part, we have the starting index, and in the next part, we have the ending index, and this is excluded. This is not part of it. So since the starting index is 1, we start from here, and the ending index is 4. So 0, 1, 2, 3, 4, and we exclude it. So this is the range 3, 5, 7, and that's what gets printed here. 3, 5, 7. Now a slice is a very special data structure that is available to us. It is very flexible and it is very useful, and its mechanism is a little different than our typical arrays. And slices are also called a reference type. They are called a reference type because a slice has always some backing array. A slice only refers to an array that is working in the background. So if you want to understand how it all works, let's imagine this. We have an array. Let's see. This is the array. And we have different indexes of the array. And let's say we have numbers 0, 1, 2, 3, 4, 5, 6. Now this is an array in Go. And its type will be the first part 1, 2, 3, 4, 5, 6, 7. 7 integer. This is the type of this array. Okay. Now, if we create a slice, now how slices work is a slice has 3 parts to it. So you can imagine a slice. We have a slice, and a slice has 3 parts. One is the length of the slice. Second, it's capacity. We'll come to capacity soon. Capacity. And the third is a pointer. And a pointer to the first element of the array, or a pointer to the first element of the array that the slice is pointing to. So in this case, it does not have to be 0. It can be this also. It can be 2 also. So now a slice, when we have a slice, it has a background array, and this slice points to this element. So this first element of the slice is 2. Now the capacity of an array, the capacity of a slice is basically starting from the element the slice points to up to the last element of the backing array, not the last element of the slice. So in this case, the capacity can be 1, 2, 3, 4, 5. The capacity is 5, and the pointer is 2. That's what it points to. And what is the length? Now length can be the same as the capacity depending on how we sliced it out of the array, or it can be different than capacity. So in this case, length can be, let's say, 3. Capacity can be 5, length can be 3. Length can also be 5. Now it's all a little confusing. Now we will see a couple of examples and it will become more and more clear. I've just shown the figure here so that we can come back to it and we can imagine and visualize how it all works. Okay, so let's get to the example first. Now here we have an example. We have an array, not a slice. We have an array whose length is 4. Now let's picture this. Here. We have this array. Okay. So let's picture this. We have an array like this. Okay. And these are the elements. So we will start the indexes from top to bottom, 0 to 3. Okay. And in the first index we have John. In the second index we have Paul. Third, George. And then we have Ringo. Okay. This is 0. Index 0 is 1, is 2, is 3. This is the array that we have. It is a fixed size array. We cannot expand it. We cannot reduce it. We cannot do any kind of changes to it. But we can slice it. Now let's understand how slices work. In this example, what we are doing, we are constructing a slice A, and it is slicing from this array from index 0 to 2. So now the slice A will have 3 parts, as I said. First part is the length. Length will be, since it is slicing from 0 to 2. So let's say 0, 1, 2, 3. 0 to 2. And since we exclude the last part, so the length is 2. Okay. And second part of the slice is capacity. You'll be more clear about the capacity after we go through some examples. For now, let's just stick to the concepts. Now the capacity, as I said, is starting from the first element of the array that this slice points to, which is 0, up to the last element of the backing array, not the last element of the slice. Now, how much is the capacity? The capacity is 4. Since we start from the first element, the capacity is the same as the backing array. Now we have the capacity 4. And we have a pointer. It has a pointer which points to John. Basically, this part, John. Okay. Now we have A. In the same way, we have B. B, what it does, it starts from the second index. Basically, index 1. So now we have length as, it starts from this index, and it goes up to the last index, 3rd. And since we exclude the last one, the length will be 2. The same way. And the capacity is starting from the first element of the array that it points to up to the last element of the backing array. Now the capacity is 3. And the pointer is, what is the element that it points to? Is Paul. Okay. This is how the physical representation of an array and the slices that come from it looks like. Okay. Now in this example, what it is trying to do is, it is doing in the array, in the slice B, it is changing the first index to XXX. What is the first index of the array B? Since it starts from here, it is trying to change the first index, the value of Paul, this part, to XXX. So now the value of Paul has been made.
Boost milkshake உடன் cool stamina. 2 அற்புதமான சுவைகளில் பாதாம் மற்றும் caramel.
XXX. Okay. And now we are printing A and B, and we are also printing the backing array. Now let's understand why are we looking at this example. Since we know slice is a reference type, and now you understand why do we call it a reference type. We have an array which is a fixed type and we cannot expand it, but we can slice from it. So we have 2 slices from the array names. One is A, another is B. Now this array, the array names, the slice A, the slice B, all three of them point to the same thing. All three of them have the same value. Names is the actual data type, and the slice A and B point to names. They are sliced from it, but they point to the same data. That's what you have to understand. A slice does not have the data for itself. It points to an array. It points to a backing array. In this case, all three of them have the same value in this position, which is Paul. And now any of them. So in this case, B has tried to make this value as XXX. Now what happens? This will change for all of them. This will change for all of them. A, B, and names. Now, if we run this, let's see what we get. Let's clear this, and if you try to run this, you can see in the first print statement. Here in the first print statement, we are getting John, Paul, George, and Ringo. And after slicing, we are printing the value of A and B. And the same way, we have John and Paul and George. Okay, nothing has changed up till now. The moment B has changed the value of Paul to XXX, now we have printed A. Now A has John and XXX. We have printed B. B has XXX and George. And we have also printed the names. There's John, XXX, George, Ringo. Now since one of the slices changed the value in that index to another value, that value got reflected in all three of them. The backing array that contains the data, and all the slices that point to that array. Okay, that's the point that this example is trying to make. Whenever a slice which is pointing to some array changes some value in that array.
भाई कुमार सर का स्टैंड आउट कब तक झेलेंगे यार? ये किस खुशी में?
क्लास टॉपर के साथ स्टैंड आउट हो रहे हैं इस खुशी में।
Changes, and all the values in all the slices that are pointing to that array, they also change. We don't always create slices out of an array. We don't have to declare an array and slice from it. We can directly create a slice. Go provides us the ability to directly create a slice, and in the background Go will create a backing array and it will give you a slice which points to that array. Okay, and that's how it will work. So this is the syntax using which you can directly declare a slice. You do not have to declare an array and slice from it. You can directly declare a slice, and this is called a slice literal. We are literally declaring a slice in one line. Okay, we have a variable declaration pattern here, with the colon equals to, and here we are saying it is a slice since there is no number in between the square brackets, which means it is a slice. That is the indication. That is the difference between an array and a slice. In an array type, you will find a number, which is the size, and it is part of the type. And in a slice, there is no number. It is a dynamic array. Okay, So this is a slice, and it is a slice of integers, and here we are providing the values during the initialization phase, and here we are printing it. In the same way, we are creating a slice of booleans, so we can only store true and false. We cannot store any other data type in a slice or in an array. It is a collection of homogeneous data types. In the same way, we can also make a slices of structs. So this is how the syntax looks like. You write a pair of square brackets, then you define the type. The same way, here we have defined the type. You can integer, boolean, or a struct. If it is a struct, you have to provide the type of the struct, and the type of the struct is this. It has two fields, I and B. I is of type integer, B is of type bool. Now, right after, since it is an slice literal initialization of type struct, okay, we have to provide all the values that goes inside this slice of structs. So we can provide, we can follow this pattern. 2 will get assigned to I, and this 2 will get assigned to B. Same way, all the structs are initialized in these slices, and then we can print it. So let's run this and see how it looks like. Okay, and we can see all the slices that got printed here. And this, since this is a slice of structs, we can see all the structs being printed here in the goes format. Now another thing is, you can also slice from another slice. Here we don't have an array here, but you can create more slices out of this slice. Okay, and also we can modify, we can make changes to this syntax. We don't always have to provide the low bound or high bound. We don't always have to provide the start index and end index. We can leave one of them and the other range will be implied. So for this case, we are saying we are slicing from the first index, from 0 to 2, and here we are saying we are slicing from index 1 up to the end. Okay, those things are implied here, and we can run this and see the example how it looks like. So we have 357 for the first, then 3, 5, and 5. Here for this we have 357 because we are indexing from here up to here, from index 1 to index 4. So we are taking 1, 2, and 3. That's why we have 357. From this we have this 3, 5, and 7. This is the value that we have. Then we can slice it again, and when we slice it, we are slicing from the first position, from 3 to the index 2. So 0, 1, 2, and we exclude the 2, so we have 5. We have 3, 5. That's why we get 3 and 5. And here we take this slice and we slice it again, and we are slicing from the first index. So this is index 0, this is index 1. So we are taking the first element is 5 and up to the end. And since this is the last element, we end it here, and that's why we have 5 here. So that's how slicing works, and you can slice from an already existing slice. You don't always have to slice from an array. You can also slice from an existing slice. Now in this example, we take a look at lengths of slices. So what we are doing here, we are defining a function called print slice. What it does, it takes a slice of integer as a parameter, and what it does, it tries to print it. And how does it format it? It is taking the length of the slice, and it is taking the capacity of the slice, and it is then taking the slice itself, and it is printing all three of them in this format. Okay, that's what this function does, and we use it here. We create a slice using the literal syntax. We say it's a slice of integer, and we provide all the integer values, and then we do the print. We call the print slice function, which displays the length, the capacity, and the value of the slice itself. The same way, what you're doing here is we are slicing from the start, because we have left the starting index from the start up to the 0 index, which basically means the length of 0. We don't want any elements because the last element is excluded, and we are starting from the start. We have now 0 elements. We don't have anything. We have an empty slice. Okay, in this print statement we should have an empty slice. Now let's picture this, how it exactly works. So for the first, initially what happens, we have initialized a slice. So we have initialized a slice. So we have a slice here, and it has a backing array, But for the sake of this example, let's imagine this is the backing array, because when you initialize a slice literal, then the length and capacity of the backing array is the same as the length and capacity of the slice. So you can imagine this slice as the backing array. Okay, now we have 2, 3, 5, 7, 11, and 13. And these are the slots, is index 0, 1, 2, 3, 4, and 5. Okay. And this is what S looks like initially in this print statement. So for this print statement, what will be the length? The length will be the initial length, which is 6. And what will be the capacity? For a slice literal, the capacity of the slice is the same as the capacity of the backing array. It has a backing array which looks exactly like this, because we initialized a slice using the literal syntax. That's why and that is the reason for the first print statement, we get length as 6 and capacity as 6. Okay. And when we print the slice, this is 2, 3, 5, 6, 2, 3, 5, 7, 11, 13. All the elements of the slice. Now, moving on. At this point, what happens? What happens is, we are saying we are starting from the start. Okay. We are starting from the start, but we go up till the 0 index. And since the last bound, the higher bound is excluded, we exclude the 0, 1. So in that case, we don't have any elements. So this is an empty slice. But what is the length here? For an empty slice, what is the length? Length is 0. Length is 0. As you can see, length is 0 because we don't have any elements yet, because the higher bound we mentioned was 0. What will be the capacity? Now, as we know, the capacity is the first element that the slice points to. In this case, it is 2. The index 0 up to the last element of the backing array. Now, this is the backing array for this slice, and that is the reason we have the capacity of 6. We have capacity of 6, and as you can see, the capacity of 6. Starting from this to this, we have 6 slots. The capacity is 6. Then what happens? At this point, we are saying we are starting from the start. For this slice, this is the backing slice, okay, and this slice points to this. Now what happens? We are starting from the 0 1 and we are going up till 4, and we are going up till 4. Now we are extending the length was 0 here, and since we have a capacity of 6, we can extend the length. What happens when we extend it? From 0 we go up till 4. Now this is 4, so now we have 2 3 5 7. We exclude the 4th index. We have 2 3 5 and 7. These are the elements of this slice. And what is the length here? The length is 4. That is the capacity here. The capacity is still 6 because starting from this, we go up to the last element of the backing array, which is this. That's why the capacity is 6. Okay, and we can see here length is 4, capacity is 6, and the elements are 2 3 5 7. Now what happens at this point? At this point, this is the backing array. Now what happens this? Now here, this is the backing array, and we slice from this slice. We slice from this, but the backing array still remains the same. Okay, this is the backing array. What are we doing here? We are starting from the second index. So we are starting from here. Second index, we include this. We are starting from 5 and up till the last element. Now last element, not of the backing array, last element of slice. When you are slicing, we go to the last element of the slice. Okay, now what is the last element of the slice? Is 7. That's why we have 7 here. Okay, and what is the length here? Since we have 2 elements, the length is 2. And what is the capacity here? Now as we know, capacity is the first element of the array that the slice points to. What is the first element this points to? This. We start from this and we go up till the end last element of the backing array. Okay, and what is the last element? 13. So how many capacity do we have? 5 7 11 13.
Have you used Claude? Around 98% of people out there are not able to use Claude to its fullest extent because Claude has many features like Claude Skill, Claude Automation, among others. If you are one of them, I'm missing out on a lot. And people who are able to use Claude to its fullest extent, they are joining companies at 1 crore, 1.5 crore packages as AI automation expert. And if you want to learn how to use Claude properly and other 15 AI tools which are going to save you 95% of your time, I invite you for my 3 hours workshop. This workshop is rated 4.92 out of 5 among 1 million workshop participants. So this workshop is not good. This workshop is freaking great. So what are you waiting for? Click on the link below, sign up for the workshop, and for first few seats, this workshop is just going to be 9 rupees. So see you inside the workshop.
Unlock your success with V10X.
That's why the capacity is 4 here. As you can see, length is 2, capacity is 4, and the slice footprint is 5.7. This is how it works. Now, as we already know, in this case, Go assigns the zero value of that data type. In case of a string, it is an empty string. In case of integer, it is 0. In case of a boolean, it is false. Okay. Now, what happens in this case? What is a zero value of a slice? What will go assign in this case? Since we are following this syntax, so ideally, if it is an integer, s's value will be 0. Since it is a slice of integer, what is the zero value of s? Let's run this and you can see, okay, this is what we get. For this println statement, we are getting s. If you try to print s, it is printing an empty array or an empty slice. The length is 0 and the capacity is 0. So for a 0 value slice, a slice which is declared without an initialization value, the length will be 0, the capacity will be 0, and it will have 0 elements. But the thing to focus here is the value of the slice itself, not talking about length or capacity or the print statement. The value of the slice will be nil. When you try to compare it, if s equals to nil, we get inside and we print this statement because the zero value of a slice is nil. So now the point here is zero value of reference types. Reference types are nil. We already know zero value of an empty string is a string in quotes. Zero value of a boolean is false. Zero value of an integer 0, and zero value of an array is all the, let's say if it's an array like for integer, then the zero value will be 0 0 0 0. Okay, this is the zero value of an array with size 4 and type integer. What is the zero value of a struct? So let's say, okay, let's come here. We have a struct, and here we have a, it's an integer, b is a string. Now, what is the zero value of this struct? The zero value of this struct is a 0 and b as an empty string. Basically, in case of an array,
உங்க 12th கட் ஆஃப்க்கு நல்ல காலேஜ் கிடைக்குமா கிடைக்காதான்னு பயத்துல இருக்கீங்களா? IIT ஸ்டூடண்ட்ஸ்
and in case of a struct, The zero value is that data structure with all the zero values of the elements. Because an array is a fixed type with 4 integers, it's zero value 0, 0, 0, 0. In the same way, since a struct has 2 fields with a integer, b string, its zero value is a is 0, b is empty string. In the same way, we have reference types. What are the reference types do we have? We have functions, we have channels, and we have pointers, we have slices, we have maps. And since we are talking about slice here, the zero value of a reference type, which is a slice, is nil. This is a very important thing to remember. The zero value of a slice is nil. Now we saw the first way to initialize a slice, which is the literal syntax. So in this case, we saw that we can declare a slice and we can initialize it like this: a, and we have integer, and we have our curly braces. We have 1, 2, 3. Okay, and we saw we can declare and initialize a slice with this syntax, with the literal syntax. We also saw we can declare a slice using var and the name of the slice and the type of the slice. And for this, the value of the slice will be nil, the length will be 0, the capacity will be 0. For this, the length will be 3, the capacity will be 3. Okay, and the value will be 1, 2, 3. We have one more way where we can initialize a slice or declare a slice is using make. A make is a function, a predefined function. Make, M-A-K-E. It's a predefined function given by Go for initializing reference types. This is something to remember. Initializing reference types only. Okay, we can use make to initialize channels, to initialize slices, to initialize maps, all the reference types that we can use make to initialize. Because we have a reason to use make instead of using the literal syntax. Why are we using make? So let's see that in this example. When we initialize a slice using make, what happens? So what we are saying is we are initializing a slice of A, and we are saying make a slice. Make, you can take it as semantically, whatever it reads like. You're saying make a slice of integer. We're saying make a slice of integer, with the second argument. The second argument.
So I'm writing an essay on cats in art history. I'm an art history major, and
to the make is the length. This is how makes signature looks like. Make, it takes three things. First is the type. And what are we providing in the type? We are providing, it's a slice of integer. It is a slice of integer. Since we also use make to declare and initialize maps, to declare and initialize channels, so we have to explicitly say that it is a slice of integer. First parameter, first argument is a type. What is the second argument? Is the length. You can say what is the length of this slice going to be. Okay. Now we already know that slices are dynamically sized. We will see how the dynamically sized mechanism works. But initially, you're saying initially the length should be 5. Okay. You're saying the length should be 5. Now there is a third parameter. There is a third parameter called capacity. We already know the mechanism of capacity. We still have not gotten the exact use case of capacity, but we'll get it soon. Now the third parameter is capacity. But by default, if you don't provide the capacity, it will take whatever the length is. So in this case, the capacity will also be 5. So now we have a print slice function. What we are doing is we are printing the length, the capacity, and the slice itself. Okay. Now in the first case, what should it print? Now that we have the theory, before you run the program, we can visualize it. For the first statement, for the first print, what we are doing, we're printing A. At this point, what's the state of A? The length will be 5 and the capacity will be 5. Okay. And now let's move on to B. What's B? Okay. Now we are using make. What is the type? The type is a slice of integer. What is the length? Length is 0. What is the capacity? The capacity is 5. Now you cannot provide a length that is greater than capacity. That is an error. Okay? That's something to remember. The capacity will be always same or greater than length. The capacity cannot be less than length. Okay? Since capacity represents the size of the backing array, so capacity will always be the same or greater than length. Okay. Now this is the state of B. Now when we call print slice, what should it print? It should print length is 0, capacity is 5. Also for A, I forgot to mention what will be the actual slice print. In case of A, since the length is A and it is a slice of integer, ideally it should print A should print 0, 0, 0, 0, 0. 5 zeros because the length is 5. What should B print? It should print an empty slice because the length is 0. So we don't have any slots to initialize it with. In case of A, the length was 5 and the type was integer. So the 0 value of a slice of integer with length 5 should be 5 zeros. Okay. Now, C. Let's move on to C. We have C here. Now we are slicing C from B. What are the properties of B? We have length 0 and capacity as 5. Okay. And what we are saying, we are saying for C, we want to slice from the 0th index to the second index. Now C, now B has the capacity of 5. B has a capacity of 5. So let's imagine B has a capacity of 5. Now for C, B is the backing array. There is another backing array, but for C, you can imagine B is the backing array. What you're saying, we are saying starting from the first index. The first index is of course 0. We want to go to the second index. So ideally we should have 0, 1, 2. Since we exclude 2, we have 0 and 1. We have 2 elements. Okay, we have 2 elements. Now what will be the elements? Since the length is 2, we are slicing 2 elements. Length is 2. And it is in slice of integers, we should have the 0 value of 2 elements, which is 0, 0. Okay, the length is 2. And what will be the capacity here? The capacity of the backing slice is 5. And we did not slice, see, we did not slice from first index or second index. We sliced from the very first 0th index. That's why the capacity does not change. The capacity only changes when you slice after the first index, after the 0th index. Any index which is more than 0, if you slice from there, then the capacity reduces. But it does not reduce when you slice from the end. Okay, that's a mental model you don't really have to understand or memorize, but you'll get it after you use slices a little bit more. Now, what is the capacity here? Capacity is still 5 because we did not slice.
நீட் ஜேஇனால ரொம்ப டஃப்பான எக்ஸாம். இவ்வளவையும் டாப் டு பாட்டம் படிச்சாதான் நம்ம பசங்களால எக்ஸாமை கிளியர் பண்ண முடியும்.
After the 0th index, we sliced from the 0th index. Now, what is D? For D, what we are saying, from C, starting from the second index, it has only 2 elements. We don't really have index 2, but we have capacity of 5. So we can slice up to 5 elements, because the capacity is 5. Okay, what you're saying, 2 to 5, since 5 is excluded, we print 2, 3, 4. Okay, print 2, 3, 4, but there are no values. values here. So we go to 0 value. What are the 0 value of integer? We have 3 zeros. It's 2, 3, 4. For index 2, index 3, index 4. What is the length now? Length is, of course, 3. What is the capacity? Now, since we sliced from the start, we did not slice from 0. We sliced from 2. Now the capacity decreases. Now, so 0, 1, 2, 3, 4. We had 5 indexes. Since we slice from here instead of here, this is gone. Now we have 3. The capacity is 3. From 5, since we sliced from index 2, now the capacity is 3. Now let's try to run this program. As you can see, for the first one, length is 5, capacity is 5. We have 0, 0, 0, 0, 0. For the second one, the slice is empty. Length is 0, capacity is 5. For the second one, we have 2 zeros. The third one, we have 3 zeros with length 3 and capacity 3. As expected, the same values that we saw in our figures. Another thing to know is we can have two-dimensional slices. A slice can contain other slices. So in this case, what we are saying, we have a slice which is a slice of another slice, and that slice is a slice of string. So we are initializing with each slice, which is a slice of string, and we are providing different strings. So this is how you declare and initialize a two-dimensional slice. We have two-dimensional arrays in a lot of languages, pretty much every language. In the same way, in Go also, we have two-dimensional slices. And if we print this, we should have some kind of matrix. And as you can see, we are printing a game of tic-tac-toe. Okay, and we can change the values using the x index and y index in different positions. That's pretty much all there is to it. It in two-dimensional slices, whatever your intuition, whatever it sounds like.
Munch Choco Fills. ഇതിലുള്ളത് അതിരടി ചോക്ലേറ്റ് ഫില്ലിംഗ്. மஞ்சோட அதிரடி Choco Fills ட்ரை பண்ணீங்களா?
Welcome to the very first video of this series, Production Grade Go from Scratch, where we actually learn stuff, not just talk about how to learn stuff. And before this is what S looks like as of now. Now what we are doing, we are trying to parameter. Now to understand okay, this is another Go provides us one more inside the Go program. Whatever your intuition, whatever it sounds like. Initially, I said that slice is a dynamic array. And dynamic means we can extend a slice, extend its length, extend its capacity, and add more elements, remove elements, all the dynamic properties that are useful in a real world application. That's why we use slice more often than we use arrays, because of their dynamic nature. Now, how do they work? How do we actually add more elements to a slice after we declare it? So this is how it works. This is the syntax. We declare a slice and we are using the var syntax. So at this point, the value of the slice will be nil, and if we print it, it will be an empty slice, and the length will be 0, the capacity will be 0. Okay, and if in the first print statements, we should get the length 0, capacity 0, and empty slice. What happens here? We are saying we are appending to this slice the first argument. So append is an inbuilt function in Go and it takes multiple arguments. The first one is the slice, which we want to append to the slice, and we are providing s here. What is the second argument? This is the element, the new element that we want to append to the slice, or that we want to push to the slice. And here the new element is 0. What happens? We had a slice which looked like this, with length 0 and capacity 0. Append does a lot of things, a lot of calculations behind the scenes, but on a high level, the reason we are provided with this function, we are provided, first thing, it takes the slice that we want to append to, takes the existing slice. As you can see here, we are providing the existing slice s. First thing, it takes the slice, and in the second parameter, it takes the new elements. Okay, and it also takes a lot of, you can also pass more arguments into the function. It is a variadic function. Go has a concept called variadic function, where a function can take any number of arguments. Okay, now append is a variadic function. You can pass any number of elements in the after you pass the slice. Okay. Now second, it can take one element like it is taking now, 0, or it can take any number of arguments. It takes two things. What it does is, first it checks the length and the capacity of the existing slice. Now what is the length and capacity of our existing slice? It is length is 0, capacity is 0. Now, if that is true, and since we are trying to add more elements into that slice, but we don't have the capacity for it, okay, the backing array that we are using in the slice, the array does not have enough capacity to it. So what append does, it assigns another memory location, another backing array whose length is 1 and whose capacity is 1, and it returns that as a return value of append. Now you are assigning it to S. Now what happens? S has length 1 and capacity 1. What happens here after that? Then at this point, S has length is 1, capacity is 1. Now this is what S looks like as of now. Now what we are doing, we are calling append again, and we are passing 1. We want to append the number 1 into this. This slice, we pass it, and append checks the capacity of the existing backing array, and since the capacity is 1, we are trying to insert another element, so we need at least 2 slots. So for that, append finds another memory location and it assigns another backing array. Now we have length as 2 and capacity as 2, and this is what the new slice looks like, and this is what we return, and we assign it to S again. Okay. Now at this step to our notepad. Now as I said, there can be two cases. One, you are inserting one element, or 2, you are inserting variadic elements. Now there are a lot of internal details, as I said, for resizing the slice inside the append function. Now we can actually take a look at how the code looks like, which resizes the slice using the append function. Now if we go here, this is actually the code which does all the resizing of the slice and all inside the Go programming language. You can see there are a lot of internal details here. And there is actually a function which is next slice capacity, the function to calculate what is the capacity of the next slice. You can see there is a threshold of 256, length of 256. If it is smaller than that, it doubles it, otherwise it does something else and all. So there are a lot of things happening here, a lot of internal details. But to have some idea about how the algorithm works, we can take a look at some of these rules. So the first rule is, if it is a single argument, if it is a single element, first thing we know, we use append to resize, to add more elements to a slice. So let's say we have a slice with length 0, capacity is 0. We have an empty slice. Now if we call append, S equals to, we take S, we pass it to append, and we add another element, let's say 1. What happens now? What append does in this case, since this is a single element, what append does, since the capacity is 0 at this point, it takes the size of the element, since this size is 1. So append finds another memory location for the new backing array, and it finds the pointer to that, and it assigns that new pointer, and that array will have a length of 1 and a capacity of 1. The first time we call append on an empty slice. What happens the second time? Now this is what the slice looks like. We have 1 here, length is 1, capacity is 1. What happens if we call append again? We call append again with S and number is 2. At this point what happens? It finds, since the capacity was 1, we are trying to insert another element, so we need capacity of 2. So it finds another memory location for the backing array and it assigns the pointer to that, to the new slice. And now the length is 2 and the capacity is 2. We'll soon notice the pattern here. Again, let's try to append another element. Append S, and this is what the slice looks like in the previous step, 1, 2. Now S3. Now at this step, what append does? Since we have capacity of 2 and we are trying to insert another element, now we need slots for 3 elements. Now what append does? It tries to find another memory location for the backing array, and the length will be now 3, but the capacity will be the double of the previous one. So previously we had capacity of 2. Now we will have the capacity of 4. Okay, so let's do one more time, then we'll see the pattern. Let's call append, then S, then we pass 4. Okay, and this is what it looked like, 1, 2, 3, and we call it once more. Now we had capacity of 4. Now we are trying to insert another element. We only have 3 elements as of now. So the append does not do anything. It has enough capacity to assign one more element. So now length will be 4, capacity will be 4, and this is what the array slice will look like, 1, 2, 3, 4. Now what happens here? One more time. Call append, call S with 5. Now we have 4 elements, we have capacity 4. We are trying to insert one more element. Now we don't have the space for that. Now what append does? Now the length is 5, capacity is 8. So it's 8, and this is what the slice will look like, 1, 2, 3, 4, 5. Now we can see the pattern. When we are trying to insert single elements, append will try to double the capacity every time there is no space. Every time there is no space, it will try to double the capacity up to as we saw here, up to the threshold is up to the length is 256. After that, it will, as it is written in the comment here, it will, instead of 2xing, it will go in the 1.25x speed. It won't double it. It will go in the speed of 1.25. It will only double it up to the length is 256 elements. After that, it will go 1.25x speed. It won't double the capacity. That is an internal detail. Now that is one pattern. And if you want to see an example for that, here we are declaring a slice with 0 value and we are starting a for loop. And in every iteration, we are appending the index into the slice. And then we are printing the length and the capacity of the slice in the print statement. Now let's run this and we'll have a fair idea how the append works behind the scenes. Okay, now if we expand it, okay, let's focus here. Let's focus what's happening. In the first iteration, the length and capacity was 0. So append made length 1 and capacity and 1, and this it is 1. In the second iteration, it inserted another index, and now the length is 2, capacity is 2. In the next iteration, when it was inserting, let's say for 0, then 1, then 2. When it was inserting 2, obviously the space was not enough, so it doubled the capacity. From 2, it went 4. Okay. Now in the next iteration, it has enough capacity. It has the capacity of 4, so it can store one more element. So that's why we can see the capacity does not change until this. The length is 4, the capacity is 4. Okay. Now in the next iteration, when we are trying to insert the index 4, now it does not have the storage anymore. Now it needs to increase the capacity again. What it did, it doubled the capacity again. The append function doubled the capacity of the internal backing array. Okay. That's what's happening here. Now we can insert 4 more elements. Up until this, we had 4 elements. Now it doubled the capacity, so we can insert 4 more elements. Now at this point, we have 8 elements and we have capacity 8, as you can see. The length is 8, the capacity is 8. Now append has to assign a new backing array. It has to increase the capacity again. Now it doubled it. From 8, it went 16. Now after this, we can insert 8 more elements. We had 8 elements, it doubled the capacity, and now we can insert 8 more elements without append having to increase the capacity, without append having to assign a new memory location. It can store the elements in the same memory location. So as you can see, length is 10, 11, 12, 13, 14, 15, 16. Now when length and capacity matches, the capacity is doubled again. So this is the pattern you can see. Every time length and capacity become same, in the next append call, the capacity doubles. Okay, that's the formula. Every time length and capacity matches, in the next iteration, append will double the capacity and it will assign a new memory location for the slice, for the new backing array. And now why am I trying to explain these internal workings of how append actually works? What is the need of it? Because most likely, this is how you'll use. You have an slice and you call append again and again. Every time you have to add more elements. You never have to think about what is the capacity, what is the length and all. Those are internal details. You will never actually have to explicitly think about the capacity and all. The append handles all those details behind the scenes. But the reason I explained how it works, what are all the things that happens behind the scenes every time you call append, every time the length and capacity matches, is because let's take an example. Up until this, let's print the value of this. Let's clear this. Go run main node go. We have length 0, capacity 0, and there is an empty slice. Now, when we try to append another element to this and we call print slice again, now what happens? Let's run this and we can see that length is now 1, capacity is 1, and we have one element in the slice. What happened behind the scenes? Append checked the capacity and it realized the slice, the backing array, does not have enough capacity to store one more element. So it searched for another memory location and it found another location for the new backing array, and the new backing array has capacity of 1 and length of 1. And as we saw earlier, if you call append again, it will do the same number of steps again, and the length will be 2, capacity will be 2, and it will keep reallocating. It will keep reallocating and finding new backing arrays every time you call append. It will try to double the capacity and it will try to do all those optimization steps to resize the slice, and all these internal calculations will keep happening when you start with a slice of 0 length and capacity. But let's imagine there is a scenario like this, when you know beforehand that you want to append to this slice 5 times. You know this information beforehand, and in this case, if you initialize with an empty slice with length 0 and capacity 0, and you run the iteration, it will work. It will definitely work. And if we can run this, and when we run this, we can see that it started with length 0, capacity 0. Then in the next iteration, capacity is 1, next capacity is 2, then capacity is 4, and then capacity is 8. Okay. And every time you know that length and capacity matches, in the next iteration, the append has to do all this internal calculation. It has to find a new memory location. It has to find a new backing array with double the capacity, and all this extra work. Every time reallocation happens because of the shortage of capacity. Now, if you know the maximum length that this slice can have, what you can do, one optimization that you can do to prevent append from doing all this extra work is this. Instead of initializing s like this, what you can do, you can remove this and you can use the short declaration form, and here you can use make, and you already know, if we use make, we can define a length and an optional capacity. Let's say we want length as 0 because we don't want pre-filled zeros inside the slice. Because if you define length as 5 and capacity is 5, it will pre-fill all those places with empty zeros. We don't want that. That's why we are saying length is 0, but capacity is 5. Maximum we'll have 5 elements, but for now, give us an empty slice. What happens if we run this now? Now, as you can see, the capacity from the first iteration is the capacity is 5, and we keep appending to it, and up until the last iteration, the capacity remains the same because we already knew that we are going to append 5 elements max, and we just prevented append, the function, inbuilt function append, from doing all those extra calculations every time there is a shortage of space. So this is something you have to remember, that we'll use, especially this syntax, that if we know beforehand what is going to be the maximum size of a slice, we can use this syntax to pre-assign a capacity beforehand to prevent append from doing all the extra work. Every time it runs out of space, Go provides us one more construct to loop over slices. We have a traditional method where we use a traditional for loop. We initialize a variable, we put a condition, we do increment in each iteration, and then we can print the index and the value using the index access method. This works. But Go provides us another construct. This is called range. And using range, you write a for, and with each iteration, Go returns two values. The first one, the index, and the second one, a copy of the value. Not the value itself, a copy of the value. This is something you have to remember. If you make any change to this value here, it won't show up in the original slice because this one is a copy in each iteration. And you can access the value of I and B here. And if you try to print this, you'll get this 0, 1, 2, 3, 4, 5, 6, 7. And if you don't want to use the index, then you can use the underscore. And if you don't want to use the value, you only want the index, then you can leave it apart. Okay. And if you want to take a look at some examples of slices in real world apps, then we can take a look at Spider. And you can see we have a lot of use cases. Here they are using the slice literal syntax to directly declare and initialize a slice in the same line. We have some make-based syntax to initialize a string slice with length 31 and capacity 31. And similarly, there are a lot of use cases everywhere in the code. Slices are one of the most common used data types in Go, and you will see a lot of examples everywhere. Okay. Here we have a range over slice accessing in Go, and you will see a lot of examples everywhere. Yeah, here we have a range over slice, accessing the value of title in each loop, and they're doing something with it, and a lot of examples like that. Now, the next data type that we have is maps. Go offers a implementation of the data type hash map, which are also called dictionary. Dictionaries, hashes, hash maps in other languages. Go also has a similar implementation. It's called map. And map, a typical structure of a map is it has a key, which is mostly string, but you can also use other data types as the key. And it has a value, and inside the value you can store anything. Okay. Maps keys has to be comparable. So comparable basically means they have to satisfy the equality operator, so that a map keys can be compared with each other. They have to have that property. That is one restriction of maps keys. And in the value you can store anything in a map. Okay. And usually we use map whenever we have a use case where we want to find things quickly. That's the mental model you should have. A lot of people get confused with when to use struct and when to use map. Struct is your typical use case whenever you want to store something, whenever you want to parse data from a JSON. A lot of use cases. In pretty much 70% of the time, we use structs. Struct are for storing values, for efficient storing values in the format of Go's native data types. In map also, you can store values, but we use maps when we want to find things quickly. Okay, because maps have the lookup time of 1, lookup time and adding time and deleting time. All these, it's a very efficient algorithm to look up things and to add things and to delete things. That's the reason we use hash maps or maps in Go to perform those kinds of tasks. Now let's understand with an example how they exactly work. So what are we doing here? We have a struct, we have a type struct, and it has two fields. One is lat and second is long, and for latitude and for longitude, and both are of type float 64. Okay, this part we already know. Then we are declaring a variable in the package level with using var syntax. The variable name is m and it is of type map. A map with key as string and value as vertex. So whenever you are declaring a map type, you have to explicitly say what is going to be the type of the key and what is going to be the type of value. Now here we declared a map. Now as you already know, map is a reference type and every reference type has the zero value of nil. So at this point, m's value is nil. Okay. Now here what we are doing, we are ignoring whatever the zero value is. We are using make. As I said, every reference type can be initialized with using make. So we are using make to initialize a map. We are not providing any length, capacity and all. We are just initializing a map using make. Then using this index-based syntax, we are storing a struct instance. A struct of type vertex. We are storing this struct in the key bell labs. Okay, this is how you store things in a map. And then we are printing it. And if you run it, we get the value of the struct. Okay? That's how maps work. You initialize a map, you store things in the keys, and you can access them using this index-based syntax. The set and get pretty much looks the same way. Now there is another syntax of initializing maps. Instead of using make, you can also use the map literal syntax. Map literal syntax basically means you just write the type and you provide the initialization value right away in the same sentence. So we are saying we are declaring a map whose key is string and the value is vertex, which is of type struct, and we are providing the keys and the values in the same line. Okay, this is another syntax to initialize maps without using make. How do you manipulate values and keys? How do you manipulate keys and values of a map? We have some of the features provided by Go. As you know, we can initialize a map using make. And also, one thing to remember when using maps are, you only have two ways to initialize maps. First, you can use the make syntax or you can use literal syntax. Third, if you try to initialize a map using var, which we do with other data types like integers, strings and slices and all. If you initialize a map, declare a map using var syntax, and if you try to assign a key in that map, then you will get an error. You will get a panic. You only have two ways of declaring a map. Either use make syntax or use a literal syntax if you know the initial values already. Okay, we can actually see this. In this example, as you can see, I have declared a map using var syntax. Okay, as we typically do with other data types like slices and integers and booleans and strings. I have declared the map using var syntax, and then I am trying to assign a key to the map. Since it's the keys of type string and the values are of type integer, I am assigning key 1 the value of 9. And then I'm trying to print this. Then what happens if I try to run this? We get a panic. We get an error that assignment to entry in nil map. Since using var syntax declares the zero value of a map, and the zero value of a map is nil. That's why we get this error that assignment to entry in nil map. What can we do in this case? We have two choices, as I said. Either we can do this, we remove the var and we do short assignment, and then we use make, and then you do this, and then we try to run this. Then we get the appropriate behavior. We have a map and the key has the value 9. We have one other choice. We can do this if you don't want to use the make syntax. We can write the type, then we can provide a curly braces. This is the literal syntax. Okay, and if you try to run this, we get the similar behavior. So as I said, when using maps, either use make or use the literal syntax. Those are the two choices that you have. Never use var to declare a map unless you know exactly what you're doing. Okay, now we have this example where we are looking at some examples of manipulating the keys of a map. Now here we initialize a map using make, and since we are using make, we are safe to assign keys to the map. Now we are assigning a key answer and we are assigning the value 42. Now we are assigning this another value to the same key, and let's try to run this, how the program behaves up to this point, up to the point here, and let's see the behavior. Now if we run this, so first we have the value 42 because we assigned 42 here with the key answer, and in the next print statement we are assigning 42 and we can see the value 42. Then what happens? We have a predefined function called delete, and using this we can delete values from a map for a particular key. So when we delete a value and then we try to print the value for that key, we'll get the zero value of the type. Since it's an integer, we are getting 0 here. Now the question here is, how do you know that whether this key answer has the value of the number 0 or the value is absent, the value does not exist? That's why the Go language is giving you the default value 0. How do you differentiate between the absent value and the 0 value? That is the question. So for that particular use case, Go provides this construct. You can try to access this value of a map using this syntax, the index-based syntax, which returns two values. The first one is a value. If the value exists, then you'll have the value here. If it doesn't, it will have the 0 value here. Then it also returns a boolean. and you can name it anything. The convention is to name it OK, so that other engineers are also aware that you're checking the existence of this value. Now we can, if the OK is true, if OK is true, then we'll know that the value exists, and whatever the value, even if the value is 0, we know that it exists, and that is meant to be the value. It is not an absent value, it is not a default value, that is meant to be the value. 0 is the value of the key answer. If it is false, then we can ignore the value and we can proceed further with whatever the expectation is. We can know that the value is not set for this key, and that's pretty much all about maps. We can do other things with a map. For example, let's say we have this, and let's remove this. And what if we want all the keys and values of a map? So we can use the range construct that Go provides to loop over slices that we can use for maps also. So let's say we write for, in the first result, it will give us the key, then it will give us the value. And in the short declaration after that, we write range, and we want to range over M, which is a map. And here we can print this fmd.println. We can write key, comma, value. And if we run this, here in the last print statement, as you can see, the key is answer and the value is 42. And using this, we can range, we can loop over maps, and we can access all the keys and values. If you don't want the key, you can use the underscore identifier here, like this, if you only want the values. And if you only want the keys, then you can get rid of that part. Now, this is how you iterate over a map. Now, another concept that I want to mention here is, let's say there are some confusions when you're starting out, that when to use map and when to use structs and all. So maps and structs have a lot of differences. For example, you cannot do this with a struct. You cannot loop over all the fields of a struct, because struct is a static type in Go. You already know all the fields and all the values of a struct somewhere. It is already written. You don't have to loop over it. That is the first difference, that you cannot range over structs, but you cannot range over, but you can range over maps. Second, all the values inside a map, like this is not a variable. This does not have a fixed memory location. You cannot use this to initialize a pointer, because this does not have a memory location. On the other hand, every struct field has a fixed memory location, and you can use that everywhere, and that memory location will be fixed, because map internally uses hashes and buckets and a lot of internal algorithms to hash and to do lookups and to add keys, remove keys and all. So they don't have fixed memory locations. The memory locations keeps changing.